In this lecture, we'll be talking about SQLALCHEMY, which is another library in Python enabling us to run SQL script. A quick recap. Before we discuss structured query languages, we learned about different data structures, including lists and dictionaries. We could organize data in dictionaries by association. However, dictionaries are limited to the size of the memory. So in practice, we design databases to save large amount of information, data, update the record, and also query information. So we briefly talked about the basics of relational database, the concept of primary key and foreign keys to connecting two tables, and also SQL script. We then learned about SQLALCHEMY library. So with importing this library, we were able to run SQL script in a Python notebook. We had three main steps, starting with creating tables, and then inserting tuples, records, and then query information. With that, let's try to answer this review quiz. Last time, we created a database named DSA5970. Now, let's try to write a query to find every class that Johnson is taking in fall 2020. In this database, we had two tables, students and takes. Under students, we save students' information, their first name, last name, and their gender, etc. And then under takes, we recorded information related to courses they are taking in each semester, and in this case, in fall 2020. At this point, I encourage you to pause the video and try to write this query and run it in Python, and then compare your codes with mine. So when you create the database, that database should show up here in the home page. For example, you can see DSA5970 that we created last time. Okay. To run the query, we define a variable, as usual, SQL command equal to quotation marks. And then we use the select statement. We want to retrieve class name and class number from two tables, takes and students. Using the where keyword, we can define the condition. Where students dot the primary key, which is the student number, is equal to takes, the other table, dot its foreign key, which is student number. With AND statement, we can add another condition. So the last name we are looking for is Johnson. And then the quotation marks. Let's run this. Then we need to execute this SQL command. So cursor dot execute. Then we pass on SQL command as an argument. Let's run this. And now we want to save the result in a variable. Cursor dot, we need to use the fetch all function. And then we can use a for loop to print results. For for rn result colon print all items. And if we run this, I run it again, and here we go. So this is the result. So this student is taking chem, and this is the course number. It's the chemical engineering, and this is the course number. Okay. So we wrote the SQL script, we executed, and then we use the fetch all function to assign all the result to the variable, and then with the for loop we can print the result, everything in that variable. Okay. Now, SQLALCHEMY is another way to use a database in Python. The difference is that commands are more like Python functions than SQL code. When we were importing SQLALCHEMY, we were literally running SQL script. So we were using select statement, from, and where keywords. And now you are going to see that the syntax when using SQLALCHEMY is more similar to Python syntax that we have seen so far. So if we want to use SQLALCHEMY, you need to install SQLALCHEMY first, and you can see this line of code, pip install SQLALCHEMY, and you just need to do it once. After installing, then we need to create database, connection, and metadata. The first step to connect to the database is to create an engine. So first we import SQLALCHEMY library and datetime library, and then we define the engine object. So SQLALCHEMY, you can see that I import SQLALCHEMY just like any other module, and then I'm using the as statement, import SQLALCHEMY as DB. Technically, I'm assigning a nickname to SQLALCHEMY, which is shorter, because Python is a case-sensitive language, and it's the SQLALCHEMY, each time I need to type it in order to get access to its function. So with as a statement, I assign DB, which is referring to that library, but is also shorter. We can avoid a typo. And datetime is another module which helps with defining date as a data structure for some attributes in our table. Now, the engine object is how we interact with the database. There are different connection styles when we are using SQLALCHEMY. Here in our course, we use SQLite. SQLite connects to file-based databases using the Python built-in module SQLite by default. So to define the engine, we call DB, which refers to the SQLALCHEMY, and then we use the function named create_engine, and then we use SQLite as the connection. And the database name is DSA5970.SQLite. And then we need to connect to create that connection. So we have a connection variable we call engine.connect. Now we have established the connection to the database. And then we have metadata. So I call DB, the SQLALCHEMY, and metadata. A metadata is a container object that keeps together many different features of a database or multiple databases being described. So we are going to define the features of our database. But first, we define this metadata. So after we establish connection, we need to create a table. And here you can see the syntax when we are using SQLALCHEMY. Let's say we are defining a table named student2. So I call SQLALCHEMY db.table, and then the table name, metadata, and then I can define columns or attributes. So db.column, and then we can define the name, a student number, and then its type. Its type is an integer, so db.integer. And if this is the primary key, then primary key becomes true. Then we can add the next column, which is first name, and its type is a string, so db.string with the maximum length of 255 characters. The next column is last name, and its type is a string. The other column is gender, its type is a string again, but with 1 character. And the last column is birth date, and its data structure is date, and that's why we imported datetime module. And we go with the default version, which is like 4-digit for years, 2-digit for month, and 2-digit for days. And at the end, we need to create this table. So we need to run the last line of code, metadata.createAll, and then we pass on engine as the argument. So let's try implement this and see what it looks like in a Python notebook. First, we import the required library, SQLALCHEMY. I assign a nickname as DB. And then we import datetime module. Then we need to define the engine object. So we call SQLALCHEMY db.create underline engine. And we are using the Python built-in module SQLite3. which connect us to file-based databases. So SQLite colon 3 forward slashes DSA 5970 dot SQLite. Let's run this to make sure. Okay. And now we establish connection. Connection is equal to engine dot connect. Then we define metadata, and to do that we call SQLALCHEMY first, and then metadata, which is a container object. Now we can define a table. So a student2 is equal to db.table. The table is student2. And then metadata, comma, and then we can define columns. db column. The first one is student number. Its type is integer, so db.integer. And this is our primary key for this table. So primary underline key is equal to true. Then comma, we can define the other columns. The other one is first name, fname, and it is a string. So db.string with maximum length of 255. Next column is last name or L name, and it is a string. Then we have gender, so db.column gender, and it's a string with 1 character. The last column is birth date, and it's a date, so db.date as a data structure, and default is true. There's a typo here. And then we need to run this line of code, metadata dot create underline all, then engine as the argument, and this one creates the table. So let's run this. So far we established the connection, and then we defined one table named student2. The next step is to insert tuples. Now we have 2 strategies. We can add 1 tuple at a time. That's what we have been doing so far. Or we can add multiple tuples using a list of dictionaries. So let's start with the first strategy. 1 tuple at a time. So we define a variable here named query. We call SQLALCHEMY db.insert as a function, and then we specify which table, and in this case is student2. Dot values. Now we want to assign values to this table, and now you can see why the syntax using SQLALCHEMY is more similar to Python syntax. And then for values, then a student number, let's say, is equal to 1. First name is Ian, last name is Ayers, and gender is M. Birth date, we import datetime module first, and then the function is also datetime. Then we have 4-digit, 2017, 12, and 20. And again, we need to execute this query first to make sure that it is assigned to the table. And let's look at the list of dictionaries. And again, the goal is to insert multiple tuples. So we define the same variable query, db.insert, so which table you want to insert tuple into, so it's a student2. And then we define a variable which is the list, values underline list, which is arbitrary. You can go with another name. So it's a list, so we see a square bracket, and then each tuple or record is a dictionary. And if you remember, for dictionaries, we needed 2 components. One is the key, the other one is value. So a student underline number or the column is the key, and then we assign value to that key using colon. So a student number, colon 44. Now 44 is assigned to this key. The other key is first name, and its value is Jag. And then you can assign, and that's how you can assign different values to columns in your table. And this is the first dictionary. Now, let's say we want to insert 2 tuples, so you add another dictionary. And now, with the same keys, a student number, now you assign new values to them. Then first name is Donald, last name is Jackson, and then you assign different values. And remember, at the end, we need to execute, but we pass on 2 arguments. First is the query, which table, and then values list, the list of dictionaries, which represent the tuples. Now let's try to implement this. First, we implement one tuple at a time. So query equal to db.insert. The table is student 2 that we just defined, and then dot values, we assign values. So a student number, the first column, let's say is equal to 1. First name is equal to Ian. Last name is equal to Ayers. And then gender is equal to M. Birth underline date is a date time. So we first import the date time module, then the function. Years is an integer, so integer 2017. Then another integer for months, 12. The integer for days, 20. So we want to make sure that we don't have any typos here. Let's run this. So there is a typo. Okay, it's missing a comma here. Let's run it again. Okay. And now we execute this command. Result proxy, it's just a variable name, connection dot execute query. Now let's say we want to insert 2 tuples using the list of dictionaries. So I define another variable query SQLALCHEMY.insert function. The table is student 2. And now I define values underline list, a variable which is a list. So you see a square brackets, and then the first tuple inside the dictionary, so curly braces, student underline number, use colon to assign the value. It's 44. First name is, let's say, Jack, and then last name is Brown, comma, and gender is M, and then comma. The last column is birth date. Quotation mark, colon, date time dot date time. We assign integer 1957 or 12, and another integer 20. So this is the first dictionary, or our tuple. Then we add the second dictionary. Now a student number is 45. The first name is Donald. The last name is Jackson. And then gender is M. The last column is birth date, birth underline date, quotation marks, colon, date time dot date time. Let's say 1917, and integer of 12 for month, then 21 for days. Make sure that we don't have any typos. So this is a list with 2 dictionaries, and each corresponds to one record or tuple in our table. Let's run this. And now we need to execute this command. So I define another variable, result, proxy, connection, dot execute. Now we pass on 2 arguments. First query that we defined here. Insert student 2, and then the values underline list, the list of dictionaries. Let me run this. Okay. So we inserted tuples, and now we can query information. Now here you can see one example. So query is another variable equal to SQL library. Then we get access to select table. We want to select from student 2. And then the keyword is where a student 2 dot columns. Then we get access to columns. And which column? A student number greater than 43. So technically we want, with this query, we want to see all students whose student number is greater than 43. So we started with selecting the table, and then the condition using the where keyword. So first we call the table columns, and then the attribute that we are looking for. And then we can execute this query using fetch all function, assign it to a variable results, and then we can write a for loop to show all items in that variable. Here you can see 3 lines of code that I would like to briefly talk about. In line 3, we are using another library called pandas, and we are going to talk about this in details. Because when we use pandas, then we get access to data frames, which present data in a tabular format. It looks like a table. And we are going to talk about this library a lot because it's very useful for analyzing data, cleaning data, etc. So I just want to show you what it looks like. So we import pandas.dataframe. So we pass on result as a data frame, and then you can see the columns and result on the under each column. So let's try to implement this. First, I implement with a for loop, just what we have been doing so far, and then I import pandas, and you can see the result. That it looks like a table. So I write the query variable db SQL Alchemy. We use select the square bracket. The table is a student 2, and then dot where. Then you can define the condition. So we get access to the table, a student 2 dot columns, and then we are looking for the student column, a student number, std underline number greater than 43. So all students whose number is greater than 43. So let's run this first. And now we save the result in a variable named results. So we need to execute this connection, execute this query. We need to apply the fetch all function. Let's run this. And then we can use a for loop to go through all items in that variable. So for r in results, print r. So let's run this. And then you can see there are 2 records. So we have 2 students whose student number is larger than 43. Now let's import pandas, the new library that I just discussed. So import pandas. And now I want, so df, I define a variable. I want to save the result in a data frame. So pandas.data frame, which is another data structure we will discuss later on. Now results. df.columns equals to results. Position 0, and then present the keys. Then we can print df. Probably the keys. Let me try. Okay, here we go. So now, first off, you can see that it's like a table. It has 2 records. By default, the first row is assigned to 0. The next row is 1, and so on. And you see the columns with their header, a student number, first name, last name, gender, and birthday. So if that's why we use pandas and data frame. Otherwise, you will see this format, 2 tables, the same information, just the format is different. So for pandas, stay tuned. We will discuss it in the future. Now I have a practice problem for you. You can follow the same format and create the same syntax and create another table named text with a foreign key, a student underline number, which is the primary key for a student. Then insert tuples. You can go with different examples, whatever you want. And now you write a query to find every class that Brown is taking in fall 2020. So this is a good practice to work with Python syntax when we are importing SQLALCHEMY, but it is very similar to what we discussed under SQL Lit 3 library. So with that, we wrap up our discussion.